Today, I'm going to show you my technique for dealing with air pockets. You'll learn how to cast tires on your own without a vacuum chamber, a vibration table, and special silicone dies. Take a look at these shots. You can see how voids form inside the tires during the casting process. This is just air that couldn't escape through the vent channels, which unfortunately results in a defective part. I've been interested in making tires for a long time. My method significantly reduces the failure rate. While it's not perfect and it does use a bit more material, the results are well worth it. Let's dive in. First, let's print the mold on an FDM printer. I specifically chose a 0.4mm nozzle and a 0.2mm layer height. I want you to see how the sidewall lettering turns out. This information might help you with your own projects later. These will be tires for a 1/16 scale RC chassis. I'll be using bolts to secure the mold parts. In future versions, I plan to simplify the design to make assembly even faster. Before we crack open the silicone containers, we need to determine the required volume. You can do this in CAD software or through online calculators. I'm using an online tool called JoulCalc. After getting the base volume, I add about 30 to 40% extra, just to ensure I have a buffer during the pour. Once we have the numbers, it's time to mix. We're using a 1-to-1 ratio. For one tire, I'll need 30 grams of the mixture. That's 15 grams of each component. I use a scale for precision, but you can also use the measuring lines on a mixing cup. Since my silicone is white, though yours might be clear, it needs to be tinted. Instead of using specialized pigments, I use laser printer toner. It's a fantastic workaround when you don't have professional chemicals on hand. Mix the solution thoroughly for 4 to 5 minutes. Remember, if the silicone isn't mixed properly, it simply won't cure. Now, this is important. Always check the pot life or working time of your silicone and whether it has self-degassing properties. Usually, this is anywhere between 10 and 50 minutes. My secret is actually very simple. I use an open pour method. I don't close the mold immediately. First, I pour the silicone into the open halves and just let it sit. In an open mold, air bubbles can escape freely on their own. Nothing is blocking them. You need to wait until the silicone starts to thicken slightly, and only then join the halves of the mold. This gives you enough time to assemble everything without losing your silicone. Then I insert the centerpieces that form the internal shape of the tire. Any excess material is just squeezed out. Yes, it's a bit messy, but the defect rate is practically zero. Leave the mold for at least 8 hours. Even if the packaging says it cures faster, it's always better to be safe than sorry. Remove the fasteners and carefully pry the mold apart, using a tool as a lever. Trim off any excess material, we call this flash, right along the seam. Remember the shot at the beginning of the video? I mentioned that we expect the same quality even from small FDM molds. Well, I didn't quite get the dream results I was hoping for. While the air pocket issue is solved, I'm honestly not happy with the surface finish and the overall detail. Let's break down why this happens together. FDM printing has some technical limits we need to consider. First, a 0.4mm nozzle and a 0.2mm layer height are actually quite huge for this scale. That's why you can clearly see the layer lines on the tire surface. Second, the nozzle diameter was just too big for fine detailing. And finally, the sidewall text didn't print at all because the line width was simply too thin. FDM takeaways. But here's the thing. My main goal was to show you my method for fighting air pockets, and we definitely achieved that. I wasn't aiming for a perfect surface just yet. I'll be pushing for that in the next video using an SLA mold. The reality is, 1/16 scale is just too small for a standard FDM mold. This type of printing is much better suited for larger scales. If you have an SLA printer, definitely use it for your tire molds. You'll get beautiful tread detail, crisp text, and an excellent surface finish. But there's one major catch. Molds printed on SLA printers often don't play nice with this type of silicone, which is a platinum-cured silicone like the one I used today. The silicone might not cure at all, leaving you with a sticky mess. I'll explain exactly why this happens and, more importantly, how to fix it in my next video. Subscribe now so you don't miss that episode on working with SLA molds. See you then!